start off with this original expression, which we're going to try and in the end integrate. That's the whole point of it. So to do this integration, we're going to try and factorise the denominator. It doesn't always factorise, but in this case it does, and we end up with this. So once it's factorised, we can then separate it out into a over x minus 3 plus b over x plus 1. And the rest of it is all about finding these numbers a and b. So first of all, we get the denominator the same. So I've got to multiply x minus 3 by x plus 1. So I multiply the top by x plus 1. And I've got to multiply this by x minus 3. So multiply the top by x minus 3. So, and the shortcut is, of course, as I'm sure you've realised, actually all I've got to do is multiply a by the denominator of the other one and b by the denominator of the other. So you sort of cross multiply to end up with this line here. And then we equate numerators. Equate numerators. And it's good mathematical method to state that, equate numerators. Okay? So we've done that, and I suppose technically, actually, if I'm talking about this thing, because we're equating them, I should say 4x minus 4 is equivalent to. So 3 lines for equivalent to, rather than equals in the sense of an equation, they're equivalent. That means they are exactly the same. So multiplying out the brackets on the left-hand side, 4x minus 16 is equivalent to ax plus a plus bx minus 3b, multiplying out all the brackets. Collecting like terms, we get this. So 4x minus 16 is equivalent to. Now we collect together terms involving x and the numbers, so we can then equate coefficients. Equate coefficients, and the coefficient means the number in front of the value x. So the coefficient of x is the number in front of it, 4 in the left hand side. Coefficient of x squared, the number in front of it, coefficient. So two equations, a plus b equals 4 and a minus 3b equals minus 16. Two equations, two unknowns, solve using simultaneous equations, either by substitution or by elimination, to get a equals, anybody do it? So, what are the answers, sorry Phil, what is a? What's your answer for a? What does a turn out to be? And b equals? A equals negative 1 and b equals? How do we check it works? Okay. Does it? Which one works in here? A is minus 1. Minus 15 is, yeah, it's this one, Phil. Minus 1 and 5. 1 and 3. 3 3s and 9. No, that doesn't work. So it must be this. A equals minus 1 and b equals 5. Then we substitute those back in to get 4x minus 4 over the original, which was x squared minus 2x minus 3, equals a, which is 1 over x minus 3, no, minus 1. So let's put the b first, the b term first. That's b over x plus 1, so 5 over x plus 1 minus 1 over x minus 3. Notice how the minus automatically gives us the sign for the fraction. We start off by saying it's a over one term plus b over the other. We're never sure whether it's going to be plus or minus, but this gives it to us. So it turns out to be 5 over x plus 1 minus 1 over x minus 3. Now, if that became an integral, we could then do the integral. Okay? So to finish this off, Tom, integrate that with respect to x. I'd actually integrate this with respect to x and take away the integral of that with respect to x. So the answer is yeah. Someone else do the other one. -1 or nothing. Yeah, just leave it. Natural log. Right. And at the end plus c. So once we get to here, dead easy to do the final integral. Okay. There's two chapters in the textbook that I want to have a look at now. One on partial fractions and one on integration using partial fractions. You see a chapter towards the end of the textbook on integration using partial fractions, as well as this section in the algebra section on partial fractions. Both of those sections have video clips in the text on the site, so you could look at the solutions. Now I'm just going to leave you to try those out.